Today's section, we'll be doing section 9.1, which is multiplying and dividing rational expressions. We will completely multiply and divide rational expressions and leave them in simplified form. When we are multiplying and dividing rational expressions, we are using the top times top, bottom times bottom method. We're going to change all division into multiplication, and when we're dealing with rational expressions are expressions that are written as fractions. Okay, these are some very simple examples of some rational expressions. Okay, 5 over 5 is a rational expression, but it reduces to 1. X plus 2 over x plus 2 is a rational expression, but it reduces to 1. Okay, we also have opposites. Opposites reduce to -1. Negative 4 over 4 reduces to -1, and they are opposites. Okay, and as a binomial, okay, when both terms are opposites, notice how on the top the x is positive and on the bottom the x is negative, and then in the numerator the 3 is negative and then the denominator 3 is positive. These are completely opposite of one another. They reduce down to -1. This is our first example. Okay, and this is just simplifying. This is not multiplication or division yet. When we are simplifying, we're taking the coefficients and simplifying them, taking any a values, b values, okay, that can simplify, any common variables that can simplify. And in terms of your groupings, okay, you have to take a common grouping. You can't just cancel out the a squared from these groupings. Okay, you have, because they are grouped in those parentheses, okay, the entire grouping needs to be canceled. Okay, so in our first step, what we would do is I'm going to look at the 2 and the 8, and I'm going to reduce that to 1 over 4. Let me write that a little bit neater for you. Reason it reduces to 1 over 4 is because 2 goes into 8 4 times. In terms of your a's, one of those a's from the denominator will cancel out one of the a's from the numerator, leaving you 1a in the numerator. In terms of the b squared, there is no b, just b. This is a b minus 3. That's a grouping. It does not cancel out with the b squared. So the b squared stays in the denominator. The entire grouping of a squared plus 4s do cancel out. There's one in the numerator, one in the denominator. They cancel out. So the grouping of b minus 3 remains in the numerator. The grouping of a minus 2 remains in the denominator. And that's our final simplified answer. There's nothing more that we can do. In our second example here, we will be, again, simplifying, not multiplying yet. You should notice that the numerator is a trinomial that most likely factors, and the denominator has a common factor of 5. So that's what we want to do. We want to factor both the numerator and denominator. So that's what's being done in this step. The numerator is being factored into x minus 3x plus 2, and the denominator is being factored into 5 times x minus 3. Now what you should see is a common grouping of x minus 3. So with that common grouping of x minus 3, those cancel each other out, and your final answer is the x plus 2 over the 5. Now we're getting into some multiplication and division. Okay, we're going to multiply and simplify at the same time. Okay, when we multiply, like the first example on this page, okay, again, think of it as top times top, bottom times bottom. Notice how I just extended a fraction bar, okay, and wrote it literally as top times top, bottom times bottom. Now we can simplify at the same time as we multiply. Okay. How did I get this first expression? Well, I simplified that both of these can be divided by 2. That's where the 2/3 comes from. Okay, where'd the b go from the denominator? The 1b from the denominator cancels 1b from the numerator, okay, leaving you with 2a squared b in the numerator and 3 in the denominator for that first expression. Okay. In the second expression, 5 goes into 10 2 times. 1a cancels out that 1a, leaving you with an a squared. Okay, and then you have your b squared left over, getting you this expression. Okay, now I can go again, top times top, bottom times bottom. Okay, leaving you with 2a squared b over 6a squared b squared. Now, 2 goes into 6 3 times. The a squares completely cancel each other out, And the 1b from the numerator cancels out one of the b's from the denominator, leaving you 1 left in the denominator. So left in the numerator is nothing, but wait, there's a 1. There's a 1 left in the numerator, 3b left in the denominator. Okay, in the second example, we have a division problem. When we're dealing with division, we change the division into multiplication. We keep the first fraction, we switch the sign to multiplication, and we multiply by the reciprocal. So it's going to look like this. Okay, we keep our same fraction in the first expression, change it to multiplication, and write the reciprocal of the second fraction. Now again, it's top times top, bottom times bottom, and we can simplify. You see that this y canceled one of these y's, leaving you with one y left over, and that's where this simplified to. Okay, now when you put them together, 72xy over 312x. Okay, 72 and 12, they can go into one another. They both are divisible by 3. So what we have here is 24 over, actually they're divisible by more than 3. Let's reverse that. Okay. 12 is divisible, or 72 is divisible by 12. It goes in 6 times. The x's cancel out, okay, leaving you with 6y in the numerator and 1 in the denominator, leaving you with just 6y. Okay. This is an expression involving trinomials, involving factoring, and division at the same time. Okay. So in this example, first thing I'm going to do is keep the first fraction, change it to multiplication, multiplication by the reciprocal. You notice that's a reciprocal. Okay. And now before I multiply, I'm going to factor all those numerators and denominators. Okay. The x minus 2 factors into x minus 1 plus x plus 1. The 2x squared minus x minus 1 factors into 2x plus 1, x minus 1. The 2x squared minus 3x minus 2 factors into 2x plus 1 and x minus 2. And then the x squared minus 4 factors into the difference of squares of x plus 2, x minus 2. Now when we multiply, okay, you see how I just put it together in terms of all together in the numerator, all together in the denominator. Now we can cancel out the common values. We have a common x minus 1. We have a common 2x plus 1. We have a common x minus 2. And now the x plus 1, x plus 2 are not in common. They are different groupings. So they are left over. Do not cancel out the x's from those groupings. Okay, they are binomials. They stay as they are. Please take a moment to do this example. Okay, in this example, we'll do this together. Okay, I'm going to go ahead and factor the first expression. Okay, it is 2x and x to get us the 2x squared, plus 1 over here to get us 2x, minus 1 over here to get us our middle term. In the denominator, again, it's 2x and x to get us our x squared term. It is plus 2 over here, minus 1 here. You can check that with your FOIL. Okay, and that should be our expression. Times, I'm going to change it to multiplication. Multiplication by the reciprocal. So in the numerator now, I'm going to write the factors of x squared plus x minus 2, which factors into x plus 2, x minus 1. In the denominator, I'm going to factor the x squared minus 1, which is our difference of squares. Okay, we change that to the reciprocal. Now, literally, all I can do is extend the fraction, change it to multiplication, and look for the common binomials that cancel out, like these 2x minus 1s, like these x plus 1s, like these x plus 2s, like these x minus 1s. Hey, look, everything cancels out. When everything cancels out, what is our final answer? It's not 0, it's 1. I'd like you to try this example. This is a compound fraction. I'm going to give you a hint before you try it, and then we will work on it in class. Okay? Think of this as your primary fraction. Okay? Change this. What is a fraction bar? What is the operation of fraction bar? The operation of a fraction bar is division. Change this into a division problem. Then keep the first fraction, change it to multiplication by the reciprocal, and simplify and solve.